Alright, welcome back. Today we are going to be working on graphing quadratics in standard and vertex form, but we're going to be learning how to transform from standard to vertex. Before we go get started, go ahead and quickly see what we learned in the last two videos. So if you notice, the left-hand side is the equation for the standard form, under ax squared plus bx plus c. When a is 1, b is 4, c is 3. When the equation is in standard form, we have to actually calculate the vertex. Remember that formula x equals the opposite of b over 2 times a. B is 4, the opposite of b is negative 4. I have 2 times a, which is 1. Put that whole thing in the calculator, we get negative 2. That is the value that goes in the middle of the x. We go 2 smaller, 2 bigger. Then we're going to substitute each of these x values into my equations every time I step to get all the y. I'm going to go ahead and do that real quick. Negative 4 would be 3. Negative 3 would be 0. Negative 2, negative 1, that's my vertex. Then I have negative 1, 0, 0, 3. Now if you notice, on the right-hand side, my equations are in vertex form. In vertex form, I can actually see the vertex from the equation. It's always the opposite sign. Instead of 2, it's negative 2. And it's the same size of the line. You just put it in and remains negative 1. I go 2 smaller, 2 bigger. Again, to find the y value, you're going to substitute as x, or by putting into your calculator and get the value. I already know the values. It's 3, 0, 0. If you notice that the exact same points, because the equations, the quadratics are the exact same. The parabola. So if you now know the equation, one was in standard form, and the other one was in vertex form. Today what we're going to learn how to do is go from standard to vertex. But I don't know about you, but graphing in vertex form is really a whole lot easier since we know the vertex. Now, to go from standard to vertex, it's this process called completing the square. And there's going to remember 3 things. The first thing is b. What is b? For my equation, we're going to use the original equation. So right here, b is 4. Then we are going to divide b by 2, which is 2. Then we're going to take this number and square it, is 4. This number is going to be a number that completes the square. So you're going to put this number right after that x, and then end it with a parenthesis. Well, don't forget, we still have that plus 3 on the outside. That plus 3 came from this equation right here, that plus 3. Now, we just can't randomly add to an equation, so to undo it, we subtract 4. Now, what we're going to do is we're going to take half of that middle term, we're going to square it, and then 3 minus 4 is negative 1. That looks like it is in vertex form, because my vertex is x plus 2 squared minus 1. Okay, let's go ahead and give this a try. Remember 3 things. What is b? B is negative 2. We're going to divide that number, b over 2, which is negative 1. Negative 1, and square it, which is positive 1. This number always is going to go right after the x, and then you're going to close it with a parenthesis. But don't forget to drop down that negative 3. But again, we just can't add 1 randomly, so we're going to subtract 1. So that's why there's a minus. Now, to get it into vertex form, always going to use this middle value. So it's going to be x minus 1, and then negative 3 minus 1 is negative. So my vertex is x squared minus 4. So here in my vertex, it's positive 1, negative 4. I'm going to go 2 smaller, 2 bigger. I'm going to go ahead and substitute those values in. I'm going to type those values right now. It's going to be 0, negative 3, negative 3, 0. Let's go ahead and those points. So it's negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3, and 3, 0. Here we know it's going to open up because it's a positive 1x squared. The axis of symmetry is going to be x equals, and it's always the x coordinate for vertex, so x equals 1. The y-intercept we have is 0, comma, negative 3. The x-coordinate, x-intercept, I have 2. I have 1 at negative 1, 0, and then I have 1, 2, 3, comma, 0. This is the vertex with 1, comma, negative 4. Alright, let's go ahead and try another example. Again, it's standard form. We're going to use this process called conforming this square to turn this equation in standard form to vertex form. Alright, so let's go ahead and apply these things. The first thing we can do is 10. The next thing we're going to do is divide b in half. So 10 divided by 2 is 5. We're going to take 5 and square it. It's 25. This number is going to go right up to the edge. So here is x squared plus 5x. We're going to have 5 and then it's get to step down to 16. Again, I just randomly can't add 25. I'm good on this. We're always going to subtract that number that you added. Here, we're going to change it to vertex one, so I have parentheses x parentheses squared. And then always going to use that middle term. So it's a positive 5, x plus 5 here. Don't forget that squared. And then 16 minus 25. So my vertex form, don't forget it for x equal to 5 squared minus 9. Now from here, it's going to open up. And let's go ahead and label the vertex. Since it's positive 5 here, the vertex would be negative 5, comma, negative 9. The axis of symmetry is always the x coordinate of the vertex. Well, negative 5. Okay. Go ahead and graph this. So I have negative 5, negative 9 here. I'm going to go 2 smaller, negative 6, negative 7. So I'm going to actually fill it out to negative 8, negative 4, negative 3, and let's go all the way to 6. Okay. A little bit. Now, to get those values, we're just going to substitute the x values into every single x right here. Or you can go ahead and do that in calculator to get all the y values. Either way is fine. So with negative 8, I have 0, negative 5, negative 8, negative 8, negative 5, and 0. Alright, so I'm plot all these. I have negative 8, 0, negative 7, negative 5, negative 6, negative 9, all the way down here. Negative 5, negative 9, oops, sorry, 1, 2, 3, negative 5, negative 6, negative 8, negative 9. Alright, make those points. I went all the way up to 3 smaller and 3 bigger just so you can see those x-intercepts right there. So my y-intercept. Now if you know this, you can actually find the y-intercept. Keep going, so it's going to be somewhere up here. Now, when the equation's written in vertex form, you can see the vertex. When it's written in standard form, you can actually see the y-intercept. This right here is the y-intercept. The intercept is lastly, my x-intercept I have 2, and at negative 8, 0, and we're going to negative 0. Alright, let's go ahead and try one more together, and we'll do the next one later on. So again, I have the equation when it's standard form, negative vertex. So first b is negative factor. Next b is divided b. So it's negative 12 plus 2 is negative 6. Then you take negative 16 squared. When you type this in the calculator, please make sure you have negative 6. And then I'm supposed to go right to that. We have x minus 12 I got plus 30, and then since we add 6 on here, we're going to subtract 36. Like next up, we've got x parentheses squared. The square goes on the outside. We're again going to use this middle term. There's a negative 6, that's going to give them a 6 right here, and 30 minus 36 is negative 6. And the vertex one is over the upper back equals minus 6 squared minus 6. We're going to open up. And from here, you can label your vertex. My vertex is going to be positive 6 because it's the opposite, and then negative 6 because it's the same. Here you always have the axis center. It's always x minus 6. Alright, let's go ahead and graph this. Remember, my vertex will be 6, negative 6. I'm going to go to smaller, bigger. Alright, my x, y values are negative 2, negative 5, negative 5, negative 2. Again, I just substituted those values in or back in. The other side, positive 4, negative 2, positive 5, negative 5, 6, negative 6, 7, negative 5, 8, negative 2. Okay. Now, when we're looking at the y-intercept, again, this quadratic, this parabola is going to keep going up and up and up. So it's eventually going to cross this y-axis, but it's just not on my 10 by 10 thing. And remember, when it's in sinus form, it is always c. So my y-intercept would be 0, comma 30. And I actually do have x-intercept, just not nice. So anytime it crosses the x-axis, so I one right here, but I'm not going to have you estimate them. All right, please go ahead and pause the video and complete number 4. Let's go ahead and check to see if you got it correct. First off, my vertex one was alpha x equals x minus 4 squared. Do not forget the squared, minus 1. I got that because I added 16 here, but don't forget to subtract 16, and then we're always going to use that negative 4 for stuff. Alright, so from here, my vertex will be positive 4, negative 1. That means my axis of symmetry is x equals 4. When I go ahead and graph this, here's on the table, here's what my graph is supposed to look like. I have two x-intercepts, one at 3, 0, one at 5, 0. Now if you notice my y-intercept, it's going to keep going up and up. So it's eventually going to intersect or cross that y-intercept up here. If you remember, it's always going to be that c value. So y-intercept is 0, 15. Alright, please go ahead and stop the video and complete the homework.